Hi class, this is Miss Northcutt and today we'll be learning about the hyperbola. These are some examples of hyperbolas on the graphs, and this is a picture of the hyperbola on a conic. And in this video we're going to be learning about the definition of a hyperbola, the types of hyperbolas, how to graph a hyperbola without using a graphing tool, and just fun little facts along the way. Here I have the formal definition of a hyperbola and the two types of hyperbolas. So the definition is a symmetrical open curve formed by the intersection of a circular cone with a plane at a smaller angle with its axis than the side of the cone. The two types of hyperbolas are the horizontal hyperbola, which as you can see is horizontal in the same way as the x-axis is, and the vertical hyperbola is vertical along the y-axis. What I have here is the equations for each, the horizontal and the vertical hyperbola. So they're not the same equation, but they are very similar. The only difference here is that the x squared and the y squared are switched on this side. So some important facts about these equations is that the a squared is always going to be under the positive term. So in this case, right here, x squared over a squared, that's the positive term, and y squared over b squared is the negative term. Same thing with this side, this is positive and this is negative. So a squared will always be under the positive term, just like in this side. A squared is under y squared because it's the positive term, and b squared will always be under the negative term on both sides. Another thing you need to know is that without seeing the graph, without knowing whether it's a horizontal or vertical graph, just by looking at the equation, if you see that the positive term is x squared, you'll know that the hyperbolas will be going left and right, okay? Left to right. And that's if the x squared is the positive term. Now if the y squared is the positive term, you'll know that it's going up, down. Okay, so it's going up and down if it's positive on the y term. And another thing to note is that the a can be greater than b, or the b can be greater than a. And so what a means in this graph is the distance between the center to the vertex right here. So the distance between here and here is a, and the distance between here and here is also a, but we can say negative a since it's going this way. And the same thing on this side, the distance from here to here is a, and from here to here, a as well. So now that we know that to get the vertex would equal positive or negative a, right? Because we put the x value first. So x value is either a, positive a, or negative a, comma 0, because the y value is right at the x-axis. It never went up and it never went down, so it stays at 0. On the other hand, for a vertical hyperbola, the vertex would start at 0, right? That's our x value because it stays right here. It never moved left or right. And our y value is either it's either positive a or negative a. So we'll write that like this. Now we're going to learn how to graph a hyperbola without using any digital helpful tools to graph. So this is our example, x squared over 4 minus y squared over 9 equals 1. So we need to remember that when the positive term right here is the x squared, we already know it's going to be going left to right. So left to right, we know that's the horizontal hyperbola, and the equation for that is x squared over a squared minus y squared over b squared equals 1. So looking at these, we know that a squared is actually 4 here, and b squared is actually 9. So we're going to write that down. A squared equals 4, b squared equals 9. So a is actually the square root of 4, which is 2. So a equals 2, and b is actually the square root of 9, so we have b equals 3. Now knowing this, we just learned previously that a this is a horizontal hyperbola, right? Because we know that the positive term is x. So we know that a is the distance between the center and the vertex of each side. So here a is 2, we're going 2 spots here, that'll be our vertex, and 2 spots here. So this is 2 and this is -2. And we know that the hyperbolas will be facing outwards and that they're going to be symmetrical. Now that we know b equals 3, we can move 3 spaces up. 1, 2, 3. Here, and 3 spaces down. 1, 2, 3. This is -3. Now what we're gonna do is draw an imaginary rectangle to connect this. So like this. So this is going to be our way of helping us draw a pretty accurate hyperbola. Now we're going to draw asymptotes as diagonals through the corners of our rectangle that we made, and it'll help us find the shape of the hyperbola we need. So we're going to do more imaginary lines here. Perfect diagonal. Perfect diagonal. These are called asymptotes. So now that we have these and they're imaginary and they go on forever and they're a perfect straight line, now we can start to draw our hyperbola. So remember, this is our vertex and we know it's opening outward. So we're just basically going to start at a curve and it's going to go really close to this line, but it's never going to touch. And that will be our shape. Same thing on the other side, you start at the vertex. Follow these lines you made. Follow these lines. Okay, so there we go. You've graphed your hyperbola. This is, we know it's a horizontal hyperbola, and now we want to find our vertex. Our vertex equals to, start with the x value, 2 or -2. Okay, so positive or -2, and it's the y value now, it's perfectly on the x-axis, so it didn't go up any. So that's our vertex, either positive or -2 and 0. And that's it for today, class. Thank you for watching.